Let's have a look at another example involving bearings, and I'm going to focus on a particular word, and that's the word from. This word appears almost 100% of the time, in a bearings question. And what comes after the word from is in fact our starting point. It's our reference. So it's kind of strange that I guess in English, we can in fact quote the beginning or where we're starting from last, and where we're ending, we quote it first. So this particular statement, town A is on a bearing of 150 degrees from town B. Where are we starting from? Okay. So let's write down what's going on here. So town A from town B. Right. What comes after the word from is in fact our starting point. If I was to write this statement in reverse order, I would write town B, change the word from to the word to, town A. Okay, so that's probably one way to think of this. If you wanted to make it something that's a little bit more understandable, you would change the word from to the word to, okay, and you would reverse the two, the two locations. So town B to town A instead of town A from town B. Okay, now that we've cleared that up, let's proceed now to answer the question. Okay, so town A is on a bearing of 150 degrees from town B. What is the bearing of town B from town A? So we know that town B is our starting point. Okay, what I'm going to do is I'm going to draw a compass rose. Okay, there's north. And from town B, I'm going to draw in where town A might be. Okay, so at least, we're going to try to draw it somewhat to scale. It's not, you don't have to draw it exactly to scale, but roughly. So 150 degrees from town B. So starting at north, remember that north is the bearing 0, 0, 0 degrees. There's east. Okay, east is at 90, 090 degrees. South is at 180 degrees. So 150 is somewhere obviously between 90 and 180. So draw an arrow. Okay, there's our town. There's town A, and that's where town A would be relative to town B. But the question is asking, what is the bearing of town B from town A? So we need to reverse this. Okay, so what I might do is I'm going to draw another compass rose, this time centered on town A. Okay, there's north there. We know that town A from town B is 150 degrees. Okay, so I'll draw that angle in there. But what we want is town B from town A. So we want this angle. Okay, so it's a bearing that we want. We want this angle there. So there's a couple of ways we can do this. Okay, we could find this angle here. Okay, complete a right angle triangle. In fact, the east-west line and the north-south line they intersect at 90 degrees, and we can form a right angle triangle. Or we could use parallel line geometry. Okay, so we can find this angle here and then subtract that from 360 degrees, and then we get the bearing of town A. The bearing of town B from town A. All right. So we know that east is 90 degrees. I think it's going to be probably easier to find this angle here. Okay. So 150 degrees to this line here, 90 degrees. If we subtract 90 from 150, okay, we get 60 degrees. Okay. So there's 60 degrees there. Now, if I was to continue this triangle along, okay, you can see that there's a right angle triangle there. Okay, angle sum of a triangle is 180 degrees. If that's 60, this must be 30. So the bearing then of B from A, okay, so this red arc here, okay, let's call that theta. Okay. Theta is going to equal 360 degrees minus 30 degrees, and that's equal to 330. Now, something interesting to note. So therefore, the bearing of town B from town A is 330 degrees. Now, it's interesting to note that anytime you have a question like this, where you have two towns or two locations, and you have the bearing of one from the other, and then you have to reverse that, what you'll notice is that there's 180 degrees between the two bearings. So 150, if you add 180 degrees to it, you get 330. Okay, and there's always this 180 degree difference, okay, between the bearings of the two towns or the bearings of the two locations. Something just well worth, I guess, just paying attention to. Okay. Anyways, regardless, we could either use the right angle triangle method, or we could use parallel line method, or using alternate angles. So if that's 60 degrees here, this would be 60 degrees there as well. West is 270, so there's west. 270 plus 60 gives you 330. Right. This one's a lot more wordier than the first one. Okay. But again, it highlights the sort of the type of problems that you might face with bearings. That the situation's actually quite straightforward, but the wording used to describe them, you can fill up half a page of just description. But the actual mathematics sort of embedded in there is actually not as substantial as it appears. Let's go through this one. Two people set off on a walk. The first person walks on a bearing of 035 degrees, and the second person walks on a bearing of 125 degrees. The first person walks 20 kilometers until the second person is due south of the first person. Find their distance apart, correct to the nearest meter. And then part 2, find how far the second person has walked, correct to the nearest meter. All right. Now, I've run out of space here, so I'm going to start drawing my solution on a second board. Okay, so you might want to have a go at this. Pause the video, have a go at this question. Okay, draw your diagram. Okay, see if you can sort of visualize what's going on here. Once you've got your diagram drawn and it's accurate and contains information in the question, answering or solving this particular problem is not that difficult. Okay, so two people are setting off on a walk. So what I'm going to do is I'm going to draw first of all, I'm going to draw a compass rose. So they're setting off on a walk. So they're leaving from the same place. Okay, so draw a compass rose. Okay, there's north. Okay, that's our origin. Okay, now it says that the first person walks on a bearing of 035 degrees. That's in the northeast quadrant. So kind of like that, isn't it? Okay, I might just draw that in. That's 35 degrees. And the second person walks on a bearing of 125 degrees. So that's in the southeast quadrant. Okay. All right, so that's the east is 90, so okay, something like that. All right, and I might just that's 125 degrees. Okay. Now we're told that the first person walks 20 kilometers until the second person is due south of the first person. So imagine that's where the first person stops. So let's call this one person 1. Person 2 is south of person 1. Probably here. Okay. Might help to draw these in pencil too, by the way. Okay. So this is person 2. Okay. Probably helps if you use the ruler, of course. Right. And we know that person 1 walked 20 kilometers. Okay. Now, there's two parts of this question. It says find their distance apart, correct to the nearest meter. Okay. So we want the distance P1, P2. Okay, and then the second part is how far has the second person walked. Okay, so let's see how we can solve this one. Now, P1 and P2 is south of P1, or P1 is north of P2. So let's see if we can add in a little bit of extra information to this diagram that's going to help us. That means that if P1 is north of P2 or P2 is south of P1, this line and this line are in fact parallel to each other. And that's going to come in very, very useful later on. You'll see why. Something else worth noting is if this is 35 degrees, okay, from north to the bearing P1, okay, and then 125 degrees from north to P2, what's the difference in the bearing between P1 and P2? So 35 degrees, what do I add to 35 to get 125? In fact, 35 degrees plus 90 gives us 125. So we've actually got a right angle here. And that's very, very useful as well, which means that we now have a right angle triangle and a pair of parallel lines that's hopefully going to help us find these distances. Okay, so this distance P1, P2, and also the distance O and P2, which is how far person 2 has walked. Okay, so we'll need another angle somewhere. Okay, so if that's 35 degrees there, okay, what must this angle be here? Okay, parallel lines, we've got a Z shape, it's alternate. That's 35 degrees up there. Now that we have a right angle triangle, we have an angle theta inside the triangle, we have a known length, we can now use right angle trigonometry to find these sides. So let's find P1, P2 first. So let's call that X and let's call that Y. And we'll solve each of these together, in fact. So let's find X. So, okay, that's a hypotenuse opposite the right angle. Okay, 20 kilometers is one of the short sides. Okay, so if I turn the triangle this way, you can probably see it a little bit easier. Okay, so that's the adjacent side, and there's the hypotenuse. Okay, so adjacent over hypotenuse, that's cosine. Okay, so cos of 35 degrees, okay, is equal to, okay, adjacent over hypotenuse. So it's going to be 20 over X. So that's our P1, P2. So I'm just going to move this board off. Okay. P1, P2. Okay. If you move the X over, X multiplied by cos 35 is equal to 20. And then dividing everything by cos 35, there's a shortcut to this, of course. 20 over cos 35. Okay. And working that out now to the nearest, it's going to be to the nearest meter. So that's in kilometers, remember? So 20 divided by, hopefully you can see that okay. Yeah. Divided by cos 35 degrees. Make sure your calculator's in degrees, of course. Okay, we get 24.415 kilometers. Okay, so I might just write that down. So, which is equal to 24.41549 ... Okay, kilometers. Multiply that by 1,000, and we get 24,415 meters. Okay, so P1 and P2 are 24,415 meters apart. Now let's find Y. Now there's two ways we can do this. We now have X. We can use Pythagoras theorem. Okay, X is a hypotenuse. So I might just put a H there. So that's our hypotenuse. Okay, that's a hypotenuse. Hypotenuse minus 20,000. So the hypotenuse squared minus 20,000 squared should give us Y squared. Okay, or again we could use right angle trigonometry. Okay, this time it's not involving the hypotenuse, it's involving the two shorter sides, which means it's going to be the tan ratio. Okay, so tan 35. Okay, is equal to opposite over adjacent. So it's going to be Y over 20. Okay, rearranging the formula or rearranging the equation, 20 tan 35 Okay, entering that into calculator. So 20, 10, 35. Okay, we get 14.004. Okay, multiplying that by 1,000, and okay, that's kilometers. Okay, and that's 14,004 meters apart. Now, just to confirm that you did this correctly, if we applied Pythagoras theorem and checked that it's a Pythagorean triple or Pythagorean triad, do we get the value of x? So let's try that. All right. In fact, 20,000 squared, if we're going to apply Pythagoras theorem, plus 14,004 squared. Okay, hopefully can you see that? Yep. And we get 24,415. 24,415. Hopefully you can see that okay. Sorry, it's just a bit dim there on the... Yep. So I think we're pretty happy with that. Okay, so there's another application of bearings.